Hello children, welcome back to physics class. Hope you all are keeping fine. So in the last video we were discussing the chapter 2 work, energy and power. In that we have seen when will be the work positive, negative and zero. Okay, let's move on to the next topic, work done by the force of gravity. Okay, that is W is equals to mgh. Okay, so let's see that. Let a body of mass m be moved down through a vertical height h, either directly or through an inclined plane. Example, a hill, slope or a stairs. The force of gravity on the body is F is equals to mg. Okay, so acting vertically downwards, and the vertical displacement in the direction of force capital S is equals to h, the height through which it has come. Okay, therefore the work done by the force of gravity on the body will be equals to, you know that the formula to find out the work done is equals to force into displacement. Here force is mg and displacement is h, so it will be W is equals to mgh. When a body of mass moves down through a vertical height, okay, it is coming down through a vertical height h, then the work done will be plus positive mgh. Okay, thus the work done by the force of gravity is same whether the body comes down from the certain height using the stairs or slope or a lift. Okay, similarly, if the body of mass m goes up, here we have seen it is coming down. Okay, when it is goes up through a vertical height h, either directly or through the stairs or a slope, the work done W will be equals to minus mgh. Since the work done by the body against the force of gravity, since it is going up, the work done by the body is against the force of gravity, therefore W is equals to minus mgh. Keep in mind, when the body comes down, then the work done by the force of gravity will be positive. Okay, that is W is equals to mgh. Okay, if it is going up, the work done by the gravity will be W is equals to minus mgh. See the unit of work. The SI unit of work is Joule and it is abbreviated as capital J. You know that the formula to find out the work done is force into displacement. Therefore, 1 Joule will be equals to 1 Newton into 1 meter. So, when 1 Joule of work is said to be done, when a force of 1 Newton displaces a body through a distance of 1 meter in its own direction. So, when do you call a 1 Joule of work is said to be done? When a force of 1 Newton displaces a body through a distance of 1 meter in its own direction, then we call 1 Joule of work is done. Okay. Next, bigger units of work are kilojoule. Kilo, you know that 1000 joules, megajoule and gigajoule, where 1 kilojoule can be written as 10 to the power 3, 1000 can be written as 10 to the power 3 joules, 1 megajoule is equals to 10 to the power 6 joules and 1 gigajoule is equals to 10 to the power 9 joules. Okay, CGS unit is erg. Okay, where 1 erg is 1 dyne into centimeter. Okay, the 1 erg of work is said to be done when a force of 1 dyne displaces a body through a distance of 1 meter in its own direction. Now you know what is a joule and erg. Let's see the relationship between joule and erg. So you know that 1 joule is equals to 1 Newton into 1 meter, but 1 Newton is equals to 10 to the power 5 dyne, and you know 1 meter is equals to 100 centimeter, that can be written as 10 to the power 2 centimeter. So this value you can substitute here. So 1 joule is equals to 1 Newton. In place of 1 Newton you can write 10 to the power 5 dyne into 1 meter, you can write it as 10 to the power 2 centimeter. So it is, you can write it as 10 to the power 5 into 10 to the power 2. A to the power m into a to the power n is equals to a to the power m plus n, right? So here m is 5 and n is 2. So it is 10 to the power 5 plus 2, 7 dyne into centimeter. So 1 joule is equals to 10 to the power 7 ergs. Okay. Next, power. Okay, the power is a rate of doing work, is called the power. Power is a scalar quantity. You know that what is a scalar quantity? A quantity which has only the magnitude, it does not depend on the direction. So power is also a scalar quantity. So let's see the measurement of power. The power spent by a source is measured as the amount of work done by the source in 1 second, or it is equal to the rate of doing work by the source. Okay, if the work W is done in time t, then the power will be work done W divided by time taken t. That is P is equals to W by T. That is the rate of doing work. Okay. The power spent by a source depends on the following factor. First one, the amount of work done by a source and the time taken by the source to do the said work. Okay, so the power spent by a source depends on two things. What are those? The amount of work done by the source, and the second one is the time taken by the source. Okay, so you know the formula to find the power, that is W divided by T, that is work done divided by time taken. Okay, the power depends on those two factors. For example, if you are carrying a bag to your room in 1 minute and your friend carries the bag in 2 minutes to the same room, the work done by both of you will be the same, but the power spent by you will be the twice than that of the power spent by your friend. Okay, since you are taking it in 1 minute and your friend carries the bag in 2 minutes, right? So the time taken by you is half of that of your friend, so your power is twice than that of the power spent by that friend. Okay, in this you are doing the work at double the rate. From this you can say that the power depends on both work as well as the time taken to do that work. Okay, let's see the SI unit of power. The SI unit of power is watt. It is abbreviated as capital W. Okay, if 1 joule of work done in 1 second, the power spent is said to be 1 watt. Okay, that is 1 watt is equals to 1 joule divided by 1 second, that is joule per second. So that is 1 watt, you know that it is 1 joule by 1 second, so it is 1 joule per second. The bigger units of power are kilowatt, megawatt, gigawatt, where you know that 1 kilowatt is equals to 10 to the power 3 watt, 1 megawatt is equals to 10 to the power 6 watt, and gigawatt is equals to 10 to the power 9 watt. Smaller units of power are milliwatt and microwatt, where 1 milliwatt is equals to 10 to the power minus 3 watt, and 1 microwatt is equals to 10 to the power minus 6 watt. Let's see the CGS unit of power, that is erg per second. And then relationship between SI and CGS units. 1 watt is equals to, you know that it is 1 joule per second, and you also know 1 joule is equals to 10 to the power 7 ergs per second. So 1 watt is equals to 10 to the power 7 erg per second. Next is horsepower. It is another unit of power largely used in mechanical engineering. It is related to the SI unit of watt as follows. Okay, 1 horsepower is equals to 746 watt, that is equals to 0.746 kilowatt. Let's see the difference between work and power. The first one, work done by a force is equals to the product of force and displacement in the direction of force. You know that work is equals to the product of force and displacement, and the power of the source is the rate of work done by the source. Power is equals to work done divided by time taken. So second one, work done does not depend on time, but the power spent depends on the time in which work is done. Third one, the SI unit of work is joule, and what is the SI unit of power? It is watt.